Okay, hello everyone. I am very happy to be here today to um, introduce the first speech session of the Start Me Up initiative. So during the week we'll have panel discussion, entrepreneur stories, and also a pitch session from different startups that are on the Paris Air Show. We'll have also some networking during lunch, starting from tomorrow, so you can come to get a drink and do some networking with people here. And yeah, I think that's all. So now we can begin with the first speech. For the first speech, I would like to invite Loïc Troutot from Santiloc. So you will have a 5-minute pitch and then 2-minute Q&A session, and you can slide here. Okay? So whenever you're ready.
Thank you. Is it working? Oh, okay, I guess. So, hello everyone. I'm Loïc from Santiloc. I'm very happy to be here today. First of all, I want to thank the Start Me Up team for giving me this invitation and the opportunity to talk with you. So, to present Santiloc. Okay. So, Santiloc has been founded in 6 years ago by 3 engineers in microchip technology. We are now 10 specialists of the NFC technology, and we are based in Aix-en-Provence, close to Marseille in the south of France. And for our technology, we have 3 international patents. Through our experience, we saw some problem and a challenge that the company must face, and our solution and technology can help the company to solve those challenge. So first of all, we help to avoid storage. We all know that if a company is run out of certain component, all the production can be impacted and even stop. So thanks to our technology, you can detect the shortage by automating your inventory, and you can even prevent disruption and downtime by automatic reorder. The second one is the searching time for the project. A fun fact, in the laboratories or factory, people lose almost 1 hour a day only to search their ingredients or their component. So it represents a big amount of waste time and also wasting money. So thanks to our technology, you can know the position of each object on your shelf instantly, so it can help you to decrease this time. The third one is the traceability. It can be really hard and a big challenge for a company to know where the product and where they will be. So thanks to our technology, you can know where is every product, who put it here, and what product is where, I would say. And the last one is the stock. It's a very big challenge to know what is inside your shelf, on your shelf, I would say. So thanks to our technology, you can visualize all your inventory and digitalize it in your ERP. I'm sorry for my English, I'm trying my best. So how does it work? You just have to plug an NFC tag on your product, put your product on the shelf, and then you will have all the position of those products, and you will get an automatic inventory all on your ERP. Here. So here's a better look on our shelves. We provide it in different size and even a hand custom size. You can have it in Wi-Fi connection, but even in wired connection. And it's kind of a big NFC reader, so you can find it in the TPE for the payment or on your phone. We have our own software to collect the data, but it's more likely to the small company or to help for the development because you have the possibility to have all the data on your own ERP thanks thanks to an API that we can give you. So this is our main customer. So we have two parts. So the first one is the retail, and the second one is more likely the industry. And I think that's all. This is all the deployment we have done. And if you have some question, I'm listening to you, but you can also find me on the stand Socomore, or you can take my number or mail, and I will be very happy to answer to your question.
Thank you, Loïc. Do we have some question? I think we're good. Thank you again, Loïc. Thanks. Okay, so now we'll go with Gabriel from Now.
Merci, bonjour. Donc, repenser la fabrication composite pour l'aéronautique agile. C'est ce sur quoi on travaille chez Nao depuis plusieurs années maintenant, avec une technologie qu'on a développée qui permet d'injecter des fibres de carbone continues, carbone ou lin d'ailleurs, continues dans des pièces imprimées en 3D. Il en résulte qu'on peut faire des pièces qui sont mécaniquement très résistantes. Le cas d'usage de cette pièce, par exemple, nous permet d'injecter 2,4 mm en section de carbone dans un tuyau de diamètre de 5. Ça paraît peut-être pas beaucoup, mais on prend quand même 9 tonnes sur 2,4 mm de carbone. Cette pièce-là, elle est faite avec une imprimante 3D FDM très classique à moins de 2000 €. Et on injecte à l'intérieur du carbone pour en faire une vraie pièce applicable dans l'aéronautique qui a une résistance mécanique très élevée. Aujourd'hui, et c'est le cas notamment dans l'aéronautique et la défense, l'innovation est très organique. Et elle fait face à une rigidité de production centralisée. C'est notre héritage de production qui implique ça. Et donc, on a des délais de fabrication longs, des coûts prohibitifs, une dépendance logistique importante, des solutions qui sont standardisées, et c'est la conséquence directe des machines qui sont très compliquées à mettre en œuvre, et une empreinte carbone largement élevée. Là, on parle de la pièce unitaire fonctionnelle ou de la petite série, qui sont les domaines dans lesquels on s'intègre très bien. Résultat, on a un modèle qui est fait pour produire beaucoup, mais pas pour produire juste. Et c'est là qu'on se positionne bien avec une technologie qui est à la fois adaptée à la pièce unitaire fonctionnelle et adaptée à la petite série, qu'on peut fabriquer chez nous à Marseille ou sur des ateliers déportés, puisqu'on est capable d'exporter les ateliers de fabrication, où on exporte les données d'ingénierie, et on est capable de fabriquer sur site chez le client. Les modes de production actuels pour les PME donc demandent des investissements initiaux qui sont beaucoup trop lourds. Les cycles d'innovation sont captifs de la production puisque ça demande de jouer sur les effets d'échelle et d'étaler sur plusieurs années la rentabilité. Et les solutions standards sont surdimensionnées, trop coûteuses et trop réactives. Chez Nao, donc, on a une approche où on a une activité de bureau d'études basée sur des outils d'ingénierie open source. Ça nous permet de collaborer de manière très efficace avec nos clients, puisqu'on partage les outils et on fait de l'intégration de compétences chez nos clients. Une technologie exclusive de renforcement d'impression 3D dans laquelle on va intégrer des fibres de carbone ou de lin continues dans des pièces imprimées en 3D. Et on joue sur les effets d'échelle quand même, puisque c'est comme ça qu'on obtient une réalité économique, mais on joue sur la partie ingénierie, où on va développer des outils, et là on tombe sur un autre de nos métiers, des outils informatiques qui sont capables de déterminer de manière automatique le placement des fibres à l'intérieur d'une pièce imprimée en 3D. Donc, notre action a un effet sur la conception, la production et finalement sur l'internalisation de nos outils chez les clients. Et si vous souhaitez produire autrement, on est à votre disponibilité au stand Safe de la région Sud dans le hall 5. Merci pour votre attention.
Thank you, Gabriel, for your pitch. Does some have any question or no? Okay, thanks. Ah.
Dans l'aéro, une fois que c'est certifié, en général, on n'y touche plus, ou plus beaucoup, sauf si problème, sauf si ça. Et comment vous entrez chez vos clients?
Alors, la certification n'est pas forcément nécessaire dans tous les domaines de l'aéronautique. Par exemple, le domaine des drones, on n'a pas forcément besoin d'une certification. Et comme notre process est beaucoup plus répétable que de la simple impression 3D, on est capable de se prévenir des amorces de cric qui sont très récurrentes dans les pièces imprimées en 3D, par exemple, par l'ajout de fibres. Et comme le procédé est répétable, on peut garder un certain niveau de paramétrisation malgré le fait que la pièce est certifiée, puisqu'on peut certifier par le procédé.
Votre cible marché, c'est quoi alors?
C'est les drones et l'aéronautique léger.
Ok, merci.
Any other question? Okay, good. Thank you, Gabriel. And now I would like to invite Nathan from EP System. Hello, Nathan. So you will have 5-minute pitch and then 2-minute Q&A. Oh, yes, on. Should be fine, yes. Perfect.
Test. All right.
In here.
Thank you.
Yes.
So 20 years ago, I was smitten with the idea of more electric airplanes. I was working as a program manager on the world's first more electric airplane, the 787 Dreamliner, and ended up certifying what proved to be the first lithium-ion battery for commercial aviation. And although we were successful in making the Dreamliner work, the hopes of an electric revolution was stalled. And the reason why it was stalled was because of safety issues with batteries and also reliability and cost issues. It's now 20 years later, and electric architectures are being called on again, but this time to defend our democracies and defend our countries. And today I want to show you one of the projects that EPS is working on and the technology we're providing to make this electrification space happen. So what you're looking at is a hybrid propulsion system for an extra large, autonomous, unmanned underwater vehicle. Now, the benefits of going to a hybrid propulsion system over, say, a nuclear reactor is cost. We can also scale these systems much faster than we can some of the legacy reactor systems. The other benefit of this type of architecture is there is no heat signature that's emitted when operating in an all-electric mode. The other benefit is it's silent. So this makes the asset completely invisible to the enemy. Now, given all the benefits of going more electric, you would think that lithium-ion batteries would be prolific across aerospace and defense, but they're not. In fact, if you're to use one example, like the United States Department of Defense, out of the some 750 megawatt hours of batteries they buy a year, only a small fraction are lithium. And the reason for that is because lithium is very difficult to deploy. If you were to take an advanced pack, such as a Tesla EV pack, and you were to subject it to the standards that the Department of Defense or the FAA or EASA would invoke upon you, eventually you're going to find that your battery, we'll see if my video works or not. Oh, looks like it's not going to work. Eventually you would find that your battery would go into what's called a full thermal runaway. I had a very nice video of you of a battery pack exploding. So what we've done to solve this is we've actually created a technology where we can contain the energy. and that we can do it at a fraction of the weight of packs that are certified today on the 787. We can also do this at a cost and a scale that's never been done before. So one of the things that makes our product unique is it's modular, and you can be configured across multiple platforms and vehicles. We've taken our product and we've actually flown on over 16 different aircraft. We've accumulated more flight time than anybody else in the world. And so if you look at what's next, or what's coming up for EPS is, oh, this is the wrong slide deck. That's all right. If you look at what's next for us is we'll be the first to certify a propulsion pack with the FAA and EASA this year. We'll also be the first to certify with the US Navy to their highest standard. And we'll also extend our lead from 16 platforms that are flying to 25 platforms this year, adding 9 new flights at hypersonic speeds. We'll actually have an asset that will land on the moon, and we feel honored to be here and to discuss a little bit our technology and how we can help your platform go electric. So thank you very much.
No, it's fine. Thanks. Thank you, Nathan, for your pitch. Do we have any question from the audience? Anyone? No, I think we're good. Thank you again for coming here. Thank you. Great. I would like to invite Quentin on stage, please, for the next speech. From Estelle. Here it is. So 5-minute pitch and the 2-minute Q&A, and here. Thank you.
Good afternoon, everybody. I'm Quentin, and we design and manufacture optical transceiver, which is mainly used for all the telecom application, which goes from AI to space agency and also on. So I will explain a bit more. So what we did, you might know, but probably 99% of those components are used in are manufactured in Asia, which is leading to different issues for firmwares and so on for cybersecurity. So the goal of Estelle was to produce and to take over all the technology again in the optical transceivers. And so what we did, we have been develop a production line here in Belgium, and then we have been setting up an R&D centers in Sweden. Yep. So the main issue we see on the market is, as I said, there's 99% of the market which is dealt by Asia. And there is no European which is able to compete. Nowadays, nobody is trying to manufacture. So it's a big gap for European in terms of security, in terms of sovereignty, and in terms of technology. This market is growing quite fast. As you might know, it's mainly driven by AI. At the before time, it was mainly driven by telecom operators. Now it's mainly driven by all the AI application. You see that it's growing as well with all the space industry, with all the satellite to make telecommunication between satellites. And so we expect to have the market growing by 30 billion for 2030. So as I explained, globally the market will be at 30 billion, which represents roughly 7.5 billion for Europe, and we roughly think that in the 5 years we'll be able to reach 500,000 just for European market. How we reach this? It's mainly by strategic partnership that we can do for with bigger industry people like Acacia, Intel, all these guys, or ST Micro in France, those people, and by making automatization as well on the production line, because all the raw material which is currently used in Asia is still technology which is coming from US. So it means that the cost of the raw material is the same. The biggest issue is on the labor cost that can be automatized nowadays. So as I explained, all the application we go for, it's depending, the market, but you can go for telecom application, which is 5G, 6G. Then you can go to AI, where you get Evident, for example, in France, which is making supercomputing here in Europe. And then afterwards, you have all the space industry with ESA, which is now working on the connection between satellite with a data rate of 100G connectivity. And then afterwards, of course, you have all the industry and then defense application, where you have issues on the firmware and on the knowledge of where the product has been manufactured and where the code is coming from. So to go after all this market, there is few targets. It's first you need to work with system vendors. And then you have what we call the telecom system vendors, which is people like Nokia, Ericsson, all these people which is based in Europe, or Equinox in France. Then you have people which is selling to telecom operators, what we call third-party optics. And then after us, you have people which is mainly focusing on data centers and AI application. So the team, it's not me only, we are multiple people, and we are lucky to have people with more than 30 years experience in this industry. Philippe is more on the, I would say, strategic side of, I would say, on the sourcing side, and then we have been our CTO, which was VP Hardware Engineering of Infinera, which is now part of Nokia, who has been developing, I would say, was a complete team of developing complete new product for optical transceivers, which goes from 1 gig to 400 and 800 gig. And that's it.
Thank you for your pitch. Any questions? Thanks. Great. And last but not least, I would like to invite Karim on stage for the last pitch of pitch session today. And we'll come back tomorrow morning with other pitch and also a panel discussion. So you will have 5 minutes, and you can use this.
So, good afternoon, everyone. I'm here to talk about ADSS, which is Aerospace Digital Standard Services. And our objective is to simplify the use of aerospace standard, which is, as you will see, not an easy subject. First, the issues. As you may know, using standards is quite difficult for aerospace companies. It's not intuitive, it's a source of errors, it's quite a pain, and it leads to costs and delays. And if you account for all the time that is spent by the aerospace companies, at least in France, you will see that it's almost 2,300 people that are involved in this subject. Our solution aims at simplifying the use of standards by digitizing the content that is originally available in like documents, PDF, and provide it as data that is easily consumable. The idea is to provide an interface that is intuitive, that is reliable, and with up-to-date data. In order to do so, the idea is to obviously save time for big companies, but also for small companies that are newcomers in the aerospace industry. Obviously avoid mistakes, because standards are in PDF format leads to a lot of mistakes. To automate the conformity assessment, because this is an important part of the use of standards. To link standards together, because when you open a standard, usually you open many standards. And obviously to optimize purchase, because at some point when you want to, for instance, buy a part, then the idea is to direct you to the right standard for the relevant part. And so our aim, our value proposition is really to focus on a service that will provide model-based standards instead of just documents, in order to save time, reduce costs, and also capitalize knowledge. Today, we provide services as well, because we are not just only a data provider, we also provide services. And we had already some deliveries to the French Defense Procurement Agency, to the French Space Agency, and the European Aviation Safety Agency. And the idea really is to reduce by 2/3 the time spent on standards. So it's really a lot of gain for either a small company or a group. The main idea here is really to focus on the fact that we are able to provide customized services that are aimed at, for instance, digitizing internal standards, not just public standards. So who we are? We are a small team today. We are 5 people internally, 3 developers, Veronique who is here, and also we have a strong advisory committee which members are coming from the industry, public entities, and who are well known in standardization. We have, like I said, two different business models. The first one is really to provide data coming from standards to the aerospace community, and the other is to really provide the service that allows for the digitization of standards to any company which are using either internal or external standards. The market is the market of the automation of compliance, and so this is a big market. It's 0.2 of the general turnover of the aerospace industry. We are aiming at European company, and even so, our target today is 25% share of that market. I think the idea is that we have a network of partners that are strongly, I would say, knowledgeable about the gain of digitizing standards, and we are currently working with some of those partners. Today, we are really not a standard distributor. We are mainly, I would say, a service provider that aims at facilitating the use of standards, facilitating compliance, and so we are quite different from usual players like you may know some of them, ISO, SAE, etc. And our key differentiator is that we have our own data models, we have a digitalization format that has been agreed with the industry, and also proprietary extraction technologies. Our roadmap is, we already secured our last exercise revenue, and we are currently doubling it this year, and we are on, I would say, an increasing pattern, which is based on two things. The first is service contracts that takes the form of proof of concept for large players, and also will lead to licensing, and so to I would say recurring revenues. And so today, how to get help from I would say the outside world is really to help manufacturers become more competitive. We have a technology lead because we are the only one who provides this kind of services. We have an experienced team. We provide sovereign solution. All the data is in France. We have a strong market potential, obviously. Involved partners, as you have seen, and the services are quite diverse, and we aim to develop a wide range of services. So thank you.
Thank you, Karim, for your pitch. Do we have any question? No, I think we're good. Thank you, Karim, again. And thank you all for coming to this first pitch session of this week. And we are waiting for you tomorrow morning, starting from 10 a.m. Thank you. Bye.